Hello, good morning, dear students, and welcome back to our class. So, today we know that we are continuing already with gravitation, and we have to move ahead with the remaining topic. Yes, in the last class, we understood that gravitation will be due to gravitational force will be more on Earth as compared to more on moon, right? Why we say that it will be more particularly on Earth itself, it is divided into two terms like at equator and at pole. You explain to me, you will purchase the gold from me at equator because it will have less weight, thereby it will have a less price. Yes, in the last class. So today we have to continue with the part and understood the weight of any object on the moon. Yes, we have understood that weight of object on Earth. It is because of weight of any object on the Earth. It is because of gravitational force which is applied or attracted by the Earth to that object or source object, right? With a small mass m. Correct? And now we have to understood how it will relate it to the weight on moon. So here the beginning for this remaining topic, weight of an object on the moon. So today we have to start with this initial topic. Along with we will understood the different terms, what is thrust, pressure, and even we have to understood the pressure in fluids. Are you getting my point here, children? Yes. So I hope you will be marking your presently there. I just want to wait for you to be here. So I will start my class. You have to be there before 1 minute, dear children. It will not be so that we have already started class and waiting for 15 minutes that you are joining class, then we can start, right? Okay. So here in the last class, what we have studied, what is the meaning of gravitational force? What is the law of gravitational force? Yes, any one of you? What is universal law of gravitation? Yes, all are busy in marking presently. Okay. So you just mark your presently up to 15 minutes and then we will begin with our important topic of the day. Yes, Hardik Jain, that two objects always attract by a force which is directly proportional to the product of the masses and inversely proportional to r square. Correct. And they will attract each other because each object which is in the universe implement the law holds good for all the object in the universe, thereby it is termed as universal law. Correct, Aditya? G and then upon d square. Correct. Okay. All objects attract each other. Correct, Ayush? Okay, so now you are answering the question means you have joined the class. Now we can start with the topic. Yes, correct part, correct Susan means Akash Saxena, of course. Right? Mohini, correct. Now children, pay attention. Now you just mark your presently and then pay attention to the class. In our last class, we understood that this value of small g is varying at pole and equator. We understood it with the example and thereby your weight of any object will be different at pole and equator. Right? Though mass will remain constant, it is not going to vary according to the location or according to the place, but weight vary according to the location, according to the place, because it depends on g, means weight of any object is its gravitational pull. Okay. And relating to this term, we even understood that this small g having a constant value near the surface of the earth, and that is nothing but 9.8 meter per second square. And thereby, using kinematical equation, as small g is constant at the surface, we can use the kinematical equation in terms of small g, and we have understood three kinematical equation in terms of small g. And now continuing that three equations, continuing or making the use of that kinematical equation in terms of g, today we will solve one numerical which is very interesting and very higher as compared to the syllabus. Okay, so pay attention. I have already written your numerical. Can you say this? A stone is allowed to fall from the top of a tower 100 meter high. Means suppose we have tower which is 100 meter high. S is equivalent to 100 meter. Okay. So a stone is allowed to fall from the top. So this is the top and stone is made to fall. Right? And at the same time, another stone is projected vertically upward with velocity of 25 meter per second. Means another stone we are throwing in upward direction and velocity will be 25 meter per second. So in this case, u will be 25 meter per second. What is u? U is initial velocity. Yes. And for this stone which is falling downward, u will be 0 meter per second. Initial velocity will be 0 for this stone which is falling down. And the initial velocity for the stone which is moving upward is given, provided us with 25 meter per second. Now, what more is given? From the ground with the velocity 20. Calculate. We have to pay attention to this point. Calculate when and where these two stones will meet. One stone is dropped from top, one stone is thrown upward. Where these two will meet, we have to find it. Okay, and even we have to find the time at which they will meet. So we will start with first condition, case 1. What is case 1? When stone is dropped, means fall. The stone is dropped, means we can calculate the value as the stone is dropped. We know that initial velocity u will be 0 meter per second. Okay, and let the displacement covered by this stone which is falling down. Displacement covered by the stone which is falling down is given as S1. Okay, for stone drop, displacement will be given as S1. Right? And what remain? For this, the acceleration A, and it is not A because it is acting due to gravitational pull, means acceleration G. Okay, and what are the sign convention? If G is downward, then it must be positive. So your G will be equivalent to plus 9.8 meter per second square. 9.8 meter per second square. This is first condition. And now how you will solve? Which kinematical equation we can use here? Which of the kinematical equation we are going to use here? We have to find what? Displacement. So we can find displacement by using the formula S is equivalent to ut plus, yes, S is equivalent to ut plus half. Now it will be replaced by G, acceleration due to gravity, into G and multiplied by T square. Right? So what will be the displacement covered by the stone which is dropping, which is falling down? It is S1. So our equation becomes S1 equivalent to 0 plus half gt square. Why 0? Because for dropping stone, initial velocity is 0. So your equation reduced to the value S1 is equivalent to half multiplied by 9.8 and the value of t will be as it is t square, right? Because we have to calculate t, we don't know what is t. So suppose they are meeting at time t, and it will be the possibility only t, right? When they are meeting, we have to find both the t's are meet, both the stones are meeting at a point. So that point will be suppose at time t. So thereby t will be as it is. We will calculate it later on. So this is your first equation in terms of S1 with the distance covered by the stone which is dropping, which is falling down. It is 9.8 divided by 2 will be 4.9 t square. This is your equation. Okay. And now we have to consider case 2. What will be our case 2? Now case 2 means the stone, when the stone is thrown upward. Okay, I am writing in shortcut. You just the stone thrown upward. The stone moves upward. What will be the initial velocity? It is provided as u equivalent to 25 meter per second. Right? What will be g? You have to be cautious here along with the sign conventions, because when you are throwing any object, it is moving opposite to the motion. Means it will moving upward, and for this condition, j will be negative. Means j is minus 9.8 meter per second square. We have learned these sign conventions already. Okay, and now by using the same formula, S equal to ut plus half gt square, we can calculate the displacement for another stone. Okay. So for another stone, we consider that displacement will be S2. So S2 will be the displacement of upward stone. Okay. So what will be the value now? S2 is equivalent to, here u term is given, means this will not be 0, it will be only 25, right, which is provided, multiplied by t, 25t, minus, why minus? Because in g it is 9.8 instead of minus 9.8, so minus half into 9.8 into t square. And what will be our S2? S2 will be written as 25t minus of 4.9 into 4.9 t square. This is our equation number 2. Okay. So from equation 1 and 2, what we have to calculate? Calculate when and where the two stones will meet. Okay. And a stone is allowed to fall from the top of a tower 100 meter high. Means the total distance between these two stones is 100 meter. Displacement, sorry, okay, is 100 meter. So we can consider by ourselves. We will get one term that this S, which is provided displacement, is the sum of displacement covered by these two stones. So thereby S1 plus S2 is equivalent to 100. Why I am taking so? Because the actual displacement between these two is 100 meter. Means S is equivalent to S1 plus S2. So from equation 1 and 2, what we will get? S1 is 4.9 t square and addition of this plus 25t and this minus of 4.9 T square. Okay, is equivalent to what? 100. So what we will get now? 4.9 T square plus minus of 4.9 T square cancel out, and 25 T is equivalent to 100, means T is 100 by 25 is equivalent to 4 seconds. Okay. So part you have given correct answer 4 seconds, but how we have to calculate, that was I am explaining. Okay. So you have to first pay attention. Yes, if G is given, we can take that value also. But suppose not given, then we have to make sure 9.8. In the last class, I have already explained you. If G is given to be 10, you can easily understand that term. If it is not given, then you have to put 9.8 meter per second square. Done. Now this will be the answer of T. Now we have find two terms. We have to calculate two terms, when and where. So when we have understood at time equal to 4 seconds, where we have to calculate. Okay, and now using at time t equal to 4 seconds, using equation 1. By equation 1, what will be the value of S1? S1 is what? Displacement covered by the stone which is dropped, which is falling down. So S1 will be equivalent to the term 4.9 multiplied by t square. Right? So 4.9 multiplied by 4 square. What will be the answer? Yes, you can give me the answer. S1 will be 4.9 multiplied by 4 square. Yes, I am waiting for your answers. And thereby the displacement, or where two stones made will be equivalent to 100 minus S. Yes, give me answer. Correct. 20 meter or 20.6 will be the, yes, displacement from the ground. Yes, but I have actually asked you S1. Then only you will subtract it, right? Correct. So correct, you all are answering correct, but I have asked you initially this. What is S1? 4.9 multiplied by 4 square. Good. 4 means times 20 square. You cannot directly answer it, right? Aditya, it will be 20.6, not 22 from the ground. Okay. So this is all we have understood the concept of. Yes, very good. Vivada, Saniya, very good. 78.4 means what will be the value? 100 minus 78.4. Yes, Aditya, now explain what is. Very good. So it will be considered as 20.6 meters. Okay, so you cannot directly write the answer where. You have to initially find using one of the equation, what will S1 either S2, and then you can explain from ground where they are supposed to meet. Yes, you can take the value of G if it is given. If not so, you can do. Both the answers will be correct. Okay. Main is the concept how to deal with this. You understood? You have to consider both the stones, their initial velocity to be understood. If it is not given, so for the term which is dropped or at a rest, considered to be initial velocity 0. But for certain another stone, it will be provided. Either it will be explained in logical ways. So here we have understood very well The value of small g is constant at the surface of the earth, and thereby we can use the mathematical equations, and by using the mathematical equation we have solved this somehow tricky question which is very important for us to be understood. Okay, so now we will move to the next topic which is very important. Today we have to start with the derivation of weight of any object on the moon, and then we will do one numerical based on it. Okay, so we understood that weight of any object is actually the gravitational force. Yes, weight of any object is gravitational force. So, weight of any object on Earth is equivalent to what? Weight of any object on Earth is equivalent to the gravitational force applied by the Earth. And that gravitational force applied by the Earth can be understood by the formula F is equivalent to G, which is gravitational constant, mass of the Earth, mass of your source object divided by distance between these two masses square. Okay? This is a standard equation for gravitational force, the universal law of gravitation. So now we will make a use of this and find the weight of an object on moon. Okay. So we knew that if it is because of gravitational force, so of course weight of any object on the moon is equivalent to gravitational force applied by the moon, and thereby we can write that weight of any object on moon will be equivalent to force or gravitational force applied by the moon. Again, that gravitational force is equivalent to the term capital G. This will be remain as it is capital G because it is a universal constant. It will not going to change at anywhere. It will remain constant on Earth, even on the moon or even on the other planet. So capital G will be as it is. Next, multiplied by mass. But your force of attraction is provided by moon. So it will be mass of moon. Capital M to the base N. Okay, mass of moon multiplied by M means mass of the source object on which the gravitational force is applied by the moon, and divided by the square of the distance between these two masses means R and square. This is our equation number 1. Weight of an object on the moon given by this equation. And similarly, we can write here weight of an object on Earth. Okay, so we can write this W is equivalent to force. So it is on Earth. So WE will be equivalent to capital G M E N upon RE square. This is our equation number 2. Right? So we have to use the reference term. We know the value of particular terms G, L. Other especially we can say it is in terms of mass of the Earth or radius of the Earth. Similarly, in NCERT we are provided with the mass of the moon and radius of the moon. So making the use of given data, we can calculate the ratio of this weight of the moon with respect to weight on the Earth. Right? By taking Earth as a reference, we can calculate the ratio for this two, and thereby dividing equation 1 by equation 2, we can get weight on moon divided by weight on Earth is equivalent to the term capital G M divided by small m R and square. Okay, and it is divided by capital G L E, mass of the earth multiplied by small m, and square of the radius of the earth. Okay. Now we can even put the values of mass of moon and radius of the moon, mass of earth and radius of the earth. Capital G will be constant, and we have taken the source object as a same mass, right? Small m. So we will easily cancel out this capital G and small m, and we will substitute the value of capital M. What will be the equation? Weight of any object on moon upon weight of object on earth is equivalent to, put the value of mass of moon, it is 7 into 10 to the power 22 divided by radius of the moon 1.7 10 to the power 6 whole square. In terms of, can you see here? In terms of capital G and small m. Are you able to see this? Yes. And divided by weight of the earth, means substitute the value of mass. It is 6 into 10 to the power 24. Right? Divided by the radius of the earth. It is 6.4 10 to the power 6 whole square. Capital G. And the common terms like capital G and G will be cancelled. Either you cancel there, or you can easily see here, you can cancel it from this side. Okay? No need to worry. As you know, you can do it. Now, by solving this term, you have to solve it. Okay? And then taking the reference, we will understand that weight of mass upon, weight of any object on moon upon weight of object on earth, the ratio will be equivalent to. This ratio will be equivalent to, if you multiply this 7 into 10 to the power 22 divided by 1.7 10 to the power 6 whole square, it will be as 2.431 10 to the power 10 in terms of Gn, which we have already cancelled out over, right? Divided by the term which is taken as 6 10 to the power 24 divided by 6.4 10 to the power 6 square whole square. So we will get the value as 1.474, but this time it is 10 to the power 11. Okay, and now the ratio is equivalent to the value 0.165, weight of moon upon weight of earth, which is nearly equivalent to 1/6. Okay, you have to solve it by yourself, you have to calculate, and you have to find whether it is correct or not. Okay, in the next class we will understand whether we have done correct or not, but you have to make sure how to cancel and how to substitute the values here. Okay, and ultimately what will be the result? Weight of moon will be 1/6 times of weight of any object on the earth. Okay, so earth is a reference for us, and we now are able to calculate the value of any object on the moon. So it is in a short, for 1 mark question or for MCQ question, you have to be very serious for this points. Weight of any object on the moon is equal to 1/6 time of weight of any object on the earth. Correct? So here we have done the very important term, weight of any object on the moon. Can we solve one numerical? See, it is given in your NCERT, page number 138, and example number 10.4. What is that? Mass of an object is 10 kg. Do I need to write it down? You can find it and very easy to, you just listen it carefully. Mass of an object is 10 kg. If we are provided mass of an object on Earth. Okay, mass of an object is 10 kg. Okay, it is simple one. We will do the next one. 10.5. An object weighs 10 Newton when measured on the surface of the earth. We will do this one. Okay. An object weighs 10 Newton when measured on the surface of the earth. Means it will be the weight of any object on the earth as 10 Newton. Okay, and we already have understood the unit of weight will be Newton because it is equivalent to force, and unit of force is Newton. So both will have as a unit as Newton. So what would be its weight when measured on the surface of the moon? Now you can explain it. Okay, we have to find what will be the weight on moon. If it is weighing 10 Newton on the earth. Very good. Are they 1.67 Newton? Very good. Nice. So are you doing it by yourself or seeing directly answers from the textbook? See, the motto behind solving the salt example is only you should aware or you should know the formulae properly, or you can go with the states, not to copy down your answers. Okay, so you have to do it yourself in your copy. Correct, Adi? Yes, you have to done by yourself. Very good. I believe you. I know that you will solve it by yourself. Yes, correct. 1.66. Correct. Correct. Akash, Saxena, Hardik. Very good, beta. Yes, Hardik. Wait. Good explanation. So here we have done with a numerical based on weight of an object of the moon. So I think you understood this concept very well, and we have done with the 30 minutes. So from module 4 we have to actually cover more points like thrust and pressure. So today we will start with that terms also, thrust and pressure, which is very important. Before that, do you have any doubt from this numericals? You have any queries, you can ask me so that we next we can move to this thrust and pressure. Yes, Ayush, Prableen, anyone? Part? Yes, you have already answered. Correct. No doubts? No queries? Okay, now pay attention. We will start with the next topic of the day, that is thrust and pressure. It is very easy and we already know the terms. But we have to provide it mathematical relation. Yes. So in physics, though we know the sentences or the phenomenon, we have to provide it mathematical terms. Then only it will be justified. Okay. So now today we will start with the definition of thrust. And based on that, we will understand what is pressure. Okay. So it is nothing new term. Thrust is nothing new, but we have to provide it with the direction, particular direction. Okay. So here we have to understood if a force is acting perpendicular to the surface, a force acting perpendicular to the surface called to be thrust, and this thrust per unit area in contact is called to be pressure. And these two definitions are so interesting, which will provide us with the various daily life examples. Initially, we just understood it, provide their relations with each other, and then I will explain you their applications in daily life. Okay? So, what is thrust? We understood that thrust is force acting or applied in perpendicular direction to the surface. Okay? And based on that, thrust is itself a force Based on that, we understood its SI unit will also be Newton. Okay. So thrust is nothing but force only applied in the perpendicular direction, means both will have the same unit. SI unit for thrust will be Newton. Now next, what is pressure? Pressure is denoted by capital P. Okay, and pressure is the thrust acting per unit area in contact. Okay, means force per unit area. And thereby you are so smart to find its unit also. Right? You understood yourself what is unit, what will be the unit of pressure in terms of these two physical quantity. One is force, another is area. The unit will be Newton per meter square. Means Newton meter to the power minus 2. Okay? And this concept was, or the definition of pressure provided by the scientist Pascal, and the honor of that scientist, we also have the unit for pressure as Pascal in terms of capital P small a. Yes, this unit will be PA as the name of scientist. This is the SI unit for pressure, either Pascal or Newton per meter square, one and the same thing. You getting my point? What is thrust? The force acting perpendicular to the surface. Correct. Right. Very good, Vibha. Swati. Good. And pressure is force acting in contact. Now come to the examples. How we can do it? If you are trying to paste a notice on notice board, okay, you want to paste a page on notice board by the use of pins. Okay. So what we do? The shape of the pin is like it consists of a head which has a large area, and that pin is then at the tip having a sharp and fine edge. Okay? Not exactly hand on, but we understood. You will apply the force here. Okay? Because it is in a perpendicular direction, means you will apply the thrust on the head of the piece. It is the pin. Okay. And this pin is in perpendicular position to this board or to this board. Okay. So this force applied in perpendicular direction is thrust, and the thrust acting per unit area is pressure. Means you are applying force on the thumb, but that per unit area will create a pressure on the board, and that paper will be pasted with the help of P on the notice. Okay. Now, how we can relate this area with the pressure, which is important to understand. If we understood that this force is constant, means the application of force is constant. The force you are applying. So you can see clearly this pressure will be inversely proportional to area. Okay. If the force is constant, then the pressure applied to it is inversely proportional to area. Means for having the large pressure, we can reduce the area. Okay, and that is what we have done at the tip of the pin. The tip of the pin is very fine, very sharp, which will help us to increase the applied force to be converted into a large pressure, so that it will be inserted in that board easily or with a thumb force only. Okay. Now one more example, the knife which we are using at our kitchen. You have seen it, you are aware about that instrument. So that knife has a very fine and very sharp edge, right? Means even with the small force applied by the mother, right? Obviously you are not working, so the force applied by mommy. So she will not waste her force, right? She will easily apply a small force and the things will be cutting so easily. Okay? It will be easy for even mother or even for us if we are doing some work. So the cutting edge will be very sharp. So with a small force you can cut the particular things or apples or whatever the veggies we are provided. But more importantly, the application in terms of like we can say their dams or building foundations are bigger. Okay, the always while we are designing building or dam, the area of foundation is very large. Of course, when a water will fall from the dam, will having a higher force and that will perpendicular to the surface in contact means creating a higher pressure, right? That force will create a pressure because in terms of that pressure is directly proportional to thrust. Pressure is directly proportional to force, right? If you are applying large force, the pressure will be large. But when force will be constant, then using area, we can reduce the effect of pressure. We can decrease the pressure by increasing the large area and thereby the foundation of the dams, the foundation of the building are large area, having large area. Okay, it is very interesting and important concept to be understood. What more example you can explain? See, you are coming to school having your bags. Okay, if suppose you have your bag straps which are on your shoulders, right? If you have to bring all the books, all the notebooks, already your bag will be very heavy. But suppose that straps instead of wider, they will be very thin, like a string only. Okay. So do it will carry a large pressure or it will be easy for you to carry it? Have you experienced this? Have you ever experienced if you're carrying your bag with full of books and notebooks? So whether it will be easy for you guys to wear it on your shoulder if it having a narrow string, a very small string, whose weight will be small. Yes, any one of you? Yes, in case of small split, it will cause much load. Yes, it will create a pain on your shoulder. It will create large pressure on your shoulder because area has reduced. The strip of your bag is small, means area will be small. Yes, and therefore you will feel much load, much pressure on your shoulders. Instead of that, school bags should have a large or wider strap. Yes, and then only it will be easy. So nowadays you are not experiencing it. You are sitting home and doing your business studies. But of course, till 8th class might you have experience and hope soon you will supposed to experience this also, right? So next time whenever you will purchase your school bags, hope the day will come soon. So try to purchase bags which will have a wider strips, okay? So that it will make easy to you carry your bags. What happened, Neela? Yes. Okay. Yes. Correct. Your answers are right. Yes, Lakshita. Yes, very good. All you children are very smart. You are attending your classes regularly. I'm glad to see that all the children are here. But who those are not yet attended any of the class, please attend your classes, do your work. And very important term, dear children, if you have done already your assignment submitted and suppose it is deleted, then you need not to resubmit it. Okay, I will write your names or take your names from my drive only. So you do next assignment within time. Okay. Okay. So any doubt from this thrust and pressure topics? Do you have any doubt? Yeah. Of course. Do you have any doubt, children? So here we are already running out of the time. So okay, if you have any doubts, we will deal it in next class. So today this is all from my side. Okay? No mutual comments, please. This is all from my side. Take care. Bye bye.